Methods of integration. In the previous video, we studied what is integration, which is nothing but the reverse process of differentiation, which was a basic session about the definition of integration and also how we get different integrals, the basic integrals like sin x, cos x, tan x and all. So we discussed all that in the previous session. Now let's come to a stage where how can we integrate and what are the different methods that we use. The first method is nothing but the method of substitution. So here we will be using the different methods of substitution to do what? Integration. Okay. So let's start with what we discussed at the end of the previous session. So I asked you whether how we can find out integral of sin x. Integral of sin x is nothing but minus cos x plus c. So that we discussed in the previous session. So integral sin x dx is minus cos x plus c. Now, I asked you what is integral sin 2x dx. What is integral sin 2x dx? Can we write integral sin 2x dx as directly cos 2x plus c? Same as how we write the derivative. The derivative of sin x is cos x. So the derivative of sin 2x is what? 2 cos 2x. That is how we studied derivatives. So in the same way, can we write integral sin 2x dx is equal to cos 2x? Or by using the chain rule or the product rule, can we use that same thing over here and say this is the integral of sin 2x? So there will be some differences. Surely there will be. And what are these differences? So I have over here sin x and now sin 2x. So there is actually a angle doubling which is happening over here. And now since the angle is doubled, I can directly do integration and say, okay, this is the value. So I need some other way of doing it. And what is the way? Whatever double angle that I have, I'm going to make it an angle which is not double, which is by taking 2x is equal to t. So what I did here is I took 2x and substituted. So what I did here, substitute 2x is equal to what? T. Now it is not a multiple of 2 or 3 or anything, right? It is just t. But there are some differences. And what is the difference? When I substitute 2x is equal to t, I am changing the value of the variable. That is, I am changing the value of variable which is from x and now I am changing that to what? T. So I am changing to t over here. So when I change from x to t, when I change the variable from x to t, the integrand, that is dx, will also change to dt. It should be changing to dt. I cannot directly integrate now with respect to dx because I have changed the variable. So I cannot do that. So I have to change the integrand also with respect to t, the new variable. So what I have to do here, simply differentiate. So what I did here is, I just need to differentiate these two. So differentiating on both sides, I will be getting 2x. What is the integral of 2x? 2dx is equal to what is the integral? What is the derivative of 2x? It will be 2dx, and what will be the derivative of t? It will be dt. So 2dx is equal to dt, or dx is nothing but dt by 2. So in place of this dx, what I'm going to write here is dt by 2. Since it is a constant, I'm taking it outside, so 1 by 2. And in place of sin 2x, I have in place of 2x what? T. So I can write it as sin t dt. Yes. So now integral sin 2x dx is now converted to half of integral sin t dt. Now what is the integral of sin t dt? Same as sin x dx, integral is minus cos x. Can we write integral sin t dt is minus cos t plus c? Yes. But there is a half outside. So what will be the integral? Half of minus cos t plus c. Now look here. In the question it was the variable x. Now we got the answer in t. So is that the final answer? It is not. We have to change the variable to the previous or the original form. So now I have to convert or go back. So 2x is equal to t. T is equal to 2x. So put in place of this t what? 2x. So what we'll be getting is minus half, take this minus outside, so minus half cos 2x plus c. So this is how I get the integral of sin 2x dx. So from sin x dx, I got the integral of sin 2x dx, which is by substituting in place of 2x, I substituted t and I got the value of the integral. Now these forms of integration by substitution can be said in which form? Integral f of ax plus b dx. So this is all of the form integral f of ax plus b dx. So when it is of this form, what you have to do is nothing but you just need to substitute. So remember the step, you just need to substitute ax plus b is equal to t. So when you substitute ax plus b is equal to t, what do you get? You get a dx is equal to dt, or dx is equal to dt by a. Or you can also write this as integral f of ax, can write it as f of t dt by a, and the value is 1 by a. What is the integral of f of t? Capital F of t. So integral is capital F of 1 by a, capital F of t plus c. So this is the first form of substitution, which is when integrals are of which form? When integrals are of the form that is f of ax plus b dx. Understood? So I hope this is clear to everyone. So integral f of ax plus b dx, put x plus b is equal to t, substitute it, go back, integrate it, and find the final answer. Okay. So one example that we can start over here is integral. We already did sine, right? So I'll go with another one. Integral tan 3x plus 5 dx. So what will be the integral of tan 3x plus 5 dx? So what you have to do here is, to find the solution, you just need to take 3x plus 5. So put 3x plus 5 is equal to t, 3 dx is equal to dt, or dx is equal to dt by 3, right? Now change tan 3x plus 5 to tan t, and this one to dx to what? dt by 3. So put the t outside, so 1 by 3. Now you have to write the integral of tan t. You don't know the integral of tan t, so for the time being, let's leave it like this. I'll directly write the answer. Integral of tan t is log mod sec t. You will be learning that in the coming sessions. For the time being, you write it as 1 by 3 log mod sec t plus c. So this gives us the integral of what? Tan 3x plus 5. So what I have used here? I have used substitution. And this is of which form? F of ax plus b form. Integral f of ax plus b dx form. Got it? Okay. So that is the first form of substitution. Now the second form of substitution is where you have integral f dash x into f of x dx. So this is the next form. So what is the second form? Integral f dash x into f of x dx. You can understand that by an example. I'll write this an example over here. Integral 3x square into e raised to x cube dx. So what I have here? 3x square into e raised to x cube dx. Look here. This 3x square over here, is it the derivative of this x cube? Yes, it is the derivative of x cube. So if I take x cube is equal to t, 3x square dx will be equal to dt. So can I take 3x square dx and write it as dt? Yes. And e raised to x cube I can write it as what? E raised to t. So now this integral became like this, that is integral e raised to t dt. And what is the integral e raised to t dt? It is e raised to t plus c. And that e raised to t, what is the value of t? Go back again and you get e raised to x cube plus c. So this is how we get the integral of 3x square into e raised to x cube dx. Understood? This is of which form? Integral f dash x into f of x dx, which are of this form. You can directly find the answer by using this substitution, because one function is the derivative of the other. So directly substitute that function as t, get the derivative as dt, substitute it, integrate, and find the final answer, which is very easy. And remember to put the final variable in the original form. So you should not be putting t there. You have to change that to x and you get e raised to x cube plus c. Got it? Okay. Now there is one more form, and what is that? It is integral f raised to n dx, f raised to nx into f dash x. One example I'll write, you will understand that. Integral tan raised to 5x sec square x dx. So what happens here is, if you have tan raised to 5x and sec square x, if I put tan raised to 5x equal to a substitution, that is t, will I be getting sec square x as the derivative? No, it won't be sec square x as the derivative. There will be difference. So what happened here is tan raised to 5x should be written as what? tan x raised to 5, right? So tan x raised to 5 sec square x dx. Now this tan x will be giving the derivative what? Sec square x, right? Yes, it is going to give the derivative sec square x. So what I have to substitute here? Substitute tan x is equal to t. So if I substitute tan x is equal to t, sec square x dx is equal to dt, right? So this sec square x dx can be now written as dt, and this tan x the whole raised to 5 will become t raised to 5 dt. And what is t raised to 5 dt integral? It will be t raised to 6 by 6. We studied integral x raised to n. What is the integral of x raised to n? It will be x raised to n plus 1 by n plus 1 plus c, right? So using that same way, integral t raised to 5 dt will be t raised to 6 by 6 plus c. Now going back, what is t? Tan x. So you can write as tan raised to 6x by 6 plus c. So this is how we got the integral of tan raised to 5x into sec square x dx. So when it is of the form f raised to nx into f dash x, put f of x as what? T. If you put f of x as t, you will be getting f dash x dx as what? Dt. So this one will become dt, or I can also write this over here. I can write it as integral t raised to n into dt. So what will be the integral of that? T raised to 6, sorry, that was the previous question. Integral t raised to n plus 1 by n plus 1 plus c. And what is t? It is f of x. So you can write it as f of x the whole raised to n plus 1 by n plus 1 plus c. And is that the same thing that we got over here? That is tan raised to 6x by 6 plus c. It was tan x and the power was 5. So add 1. So n plus 1, 5 became 6 here, and the denominator also became 6. So tan raised to 6x by 6 plus c. So that is how we get the third way of substitution here. Understood? So these are the three different ways of substitution that we have just learned. Now we will wind up the session by learning some problems so that we have a clear idea of what all we have learned. Yeah, so we have our first question over here, integral sine x, sine of cos x dx. So to integrate this one, when we are learning method of substitution, it's very easy because we just need to think about substitution for the time being. For example, if I teach you integration by parts, integration by different other methods, and then we look at this question, we tend to think of other methods also to do this question. For the time being, just think of substitution. So what is the substitution that I can use here? You can see that you have a cos x inside, right? If I take cos x and take the derivative, or substitute it and take the derivative, will I be getting something in terms of sin x? Yes. So what I do here is take cos x is equal to t. And what is the derivative of cos x? Minus sin x. So minus sin x dx is equal to dt, or from this sin x dx is equal to what? Negative dt. So this sin x and this dx will get the value minus dt. So minus, I take it outside, and the sin x and dx I write it as dt. Now sin cos x. So cos x is t. So sin cos x will be sin t dt. So minus sin t dt. What is the integral of sin t? It is minus cos t. Integral of sin t is minus cos t. So minus sin t integral will be simply cos t. So cos t plus c. So what is the final answer? It is nothing but cos t plus c. And is that the final? No, because we have to put it back into which one? X. So what is x here? It is cos x. Sorry, what is t here? It is cos x. So cos of cos x plus c. So the final answer is nothing but cos of cos x plus c. Clear? Okay. Now moving on to the next question over here, we have to find the integral of 4x plus 2 into root of x square plus x plus 1 dx. To find the integral of this one, again substitution, but look here, 4x plus 2 root of x square plus x plus 1, where to substitute? That's the question, right? Let's try a substitution. What is inside this root? X square plus x plus 1. So if I take x square plus x plus 1 and substitute equal to t, and now if I take the derivative, I get 2x plus 1 into dx is equal to dt, right? Yes. So I get 2x plus 1 dx is equal to dt. But you have 4x plus 2 over here. I have 2x plus 1 now. So there is a slight difference between this 4x plus 2 and 2x plus 1. What is the slight difference? Just a 2, a multiple of 2. So what I'm going to do here is I'm going to multiply this 2 here. And when I multiply this 2 inside, I'll be getting 4x plus 2 dx is equal to 2 dt. So instead of 2x plus 1 dx is equal to dt, now I got 4x plus 2 dx is equal to 2 dt. So this 4x plus 2 dx can now be written as what? 2 dt. So integral 2 dt, I'm writing it over here. And this one becomes what? Inside the root I have only t. So root t. And you know what? Root t is nothing but t raised to 1 by 2. So what is the integral of t raised to 1 by 2? It will be t raised to 1 by 2 plus 1 by 1 by 2 plus 1 plus c. So you can write it as 2 into t raised to 1 by 2 plus 1 by 1 by 2 plus 1 plus c. That is nothing but 2t raised to 3 by 2 by 3 by 2 plus c. Or finally you can write it as 4 by 3 t raised to 3 by 2 plus c. Final answer? No. Put the t back to in form of x. So what is t? X square plus x plus 1. So putting that back, you get 4 by 3 x square plus x plus 1, the whole raised to 3 by 2 plus c. You get the final answer for this particular question. And what is the substitution that I have used? In place of root of x square plus x plus 1, in place of that x square plus x plus 1, I put a t, but not directly I got 4x plus 2. I just need to multiply again by a 2. And now I got the answer. And that is how you find the integral of this particular function. Next, you have a third question, x cube into tan inverse x raised to 4 by 1 plus x raised to 8. How to substitute here? You will know that what is the derivative of tan inverse x? Is it 1 by 1 plus x square? Yes. Tan inverse x derivative is 1 by 1 plus x square. But you have tan inverse x raised to 4. So let's try to put tan inverse x raised to 4 as t. So when I take tan inverse x raised to 4 as t, I can take the derivative of 1 by 1 plus x square. In place of x square, I have x raised to 4. So what is the square of x raised to 4? X raised to 8. And using chain rule, what is the derivative of x raised to 4? 4x cube dx is equal to what? dt. So this is the derivative of what? Tan inverse x raised to 4 with respect to x. That is 1 by 1 plus x raised to 8 into 4x cube dx is equal to what? dt. Now check here. I have x cube. I have 1 plus x raised to 8. Now this 4 is not there. So I'm taking this 4 down. So I have x cube by 1 plus x raised to 8 dx is equal to what? dt by 4. So this x cube by 1 plus x raised to 8 dx can be now written as what? dt by 4. So integral dt by 4. So 1 by 4 outside. X cube by 1 plus x raised to 8 dx is what? dt by 4. So I write it like this. And what is left? Tan inverse. And tan inverse x raised to 4 can be written as what? t. So tan inverse x raised to 4 is now written as t. So t dt. And what is the final answer? What is the integral of t dt? It is t square by 2 plus c. And that is t square by 8 plus c. And what is t? Tan inverse x raised to 4. So t square is tan inverse x raised to 4 the whole square by 8 plus c. And that is how you find the integral of x cube tan inverse x raised to 4 by 1 plus x the whole raised to 8 dx. Understood? And the last question of this session, integral of root sine 2x cos 2x dx. Direct question. Put sine 2x as what? T. So when you put sine 2x as t, what is the derivative of sine 2x? Cos 2x dx. No, 2 cos 2x dx. And that is equal to dt. Or from this, what is cos 2x dx? You get it as dt by 2. So this cos 2x dx can now be written as what? dt by 2. So you write it like this. This one becomes root t and this one becomes dt by 2. So dt by 2. And what is the integral of root t? It is t raised to 3 by 2 by 3 by 2 plus c. So this gets cancelled and you have 1 by 3 t raised to 3 by 2 plus c. And what is t? It is sine 2x. So you have 1 by 3 sine raised to 3 by 2 2x plus c. So this gives us the final answer for the integral of root sine 2x into cos 2x dx. So in this session, we have discussed different methods of substitution, right? There are many other methods of integration, not just substitution. There are different methods which we will be learning in the coming videos. Until then, keep exploring.
Manorama Horizon. Learning made simple.